Hey y'all, Dr. G here. In this video we're going to explore a couple different ways of working with exponents and powers of 10 specifically. Okay, we're going to start by thinking about some fairly simple algebra where we are multiplying or dividing powers of 10 to certain exponents. Okay, so for example, if we have something like 10 to the third times 10 squared. How do we deal with this? Okay, if you want to, you can put it in your calculator, and that is not a bad approach. You're almost guaranteed to get the right answer. But by understanding how to work with this without a calculator, you can save yourself a lot of time. Okay, so the trick when our base number is the same and we are multiplying values raised to certain powers is that if it's multiplied, we add the exponents. So here it is 10 to the 3 plus 2, or 10 to the 5th. Okay? So when we are multiplying powers of 10 or exponents, we add the value of the exponent. Okay? If you want to get a little bit more detailed explanation, we can do that. 10 to the third is 10 times 10 times 10. We're multiplying this by 10 squared, which is 10 times 10. So what we see here is here we have 3 tens, here we have 2 tens. Overall, we have 5 tens. So 10 to the power of 5. Okay? You don't have to write this all out or put it in your calculator as long as you understand that 10 to the power of 3 times 10 to the power of 2 is the same as 10 to the third, 10 to the 3 plus 2, or 10 to the 5th. Okay? It's just as easy to work with division. So if we have something like 10 cubed divided by 10 squared. Well, if multiplication here is addition, then division is going to be subtracting our exponents. Okay, so this is going to be equal to 10 to the 3 minus 2 because we're dividing, or 10 to the first power. Okay, another example. 10 to the 8th divided by 10 to the 4th. Okay, in this case, it's divided, so we subtract our exponents. 10 to the 8 minus 4, or 10 to the power of 4. Okay, so pretty straightforward. It shouldn't be especially tricky. Things can get a little more tricky though when the expressions are represented in different ways. Okay, so for example, if we have 10 to the 8th written as 10 to the 8th over 10 to the 4th, this is mathematically exactly the same as this. These two expressions are equivalent. So if you want to, you can write this out as 10 to the 8th divided by 10 to the 4th and write it out as 10 to the 4th. Alternatively, you can recognize that this is a division process, so we have 8 minus 4 giving us 10 to the 4th. Either approach is fine. How about a situation where we have a negative exponent? Okay, we saw in the previous video that negative exponents mean 1 over that value. So let's explore this. So if I have something like 10 to the 4th times 10 to the negative 6th. Okay, we recognize that 10 to the negative 6th means 1 over 10 to the 6th. So another way of writing this would be 10 to the 4th divided by 10 to the 6th. And now we recognize it as looking something like this, so we can work with it. 10 to the 4th divided by 10 to the 6th, this equals 10 to the negative 2. Okay? Another way of thinking about it is that this is still a multiplication. So we're going to add together our exponents. So this is equal to 10 to the fourth plus negative 6, or 10 to the negative second. Okay? So don't let negative exponents confuse you. You work with them, you treat them in exactly the same way as you would if you're dealing with positive exponents. The nice thing about understanding a process like this, converting 10 to the negative 6th to 10 over 1 to the 10 to the 6th, is that you can then manipulate the expression to be in a way that's useful for you, right? There are multiple ways of solving problems like this, so you can find the way that works best for you. In the next video, we're going to explore what happens when we have an exponent raised to a power.